Okay, for this video, we're going to take a look at the even and odd formulas, and I'm going to demonstrate this using just a real quick unit circle reference here. And so we want all, and then we have sine, tangent, and cosine over here. And if you recall, if the terminal angle, or I'm sorry, the terminal side lands in those quadrants, then that particular trigonometric ratio and its reciprocal are going to be positive. So let's take a look at, if I have this angle right here, okay, that's going to be a positive theta. And we know that if I want a negative theta, it would just be going in this direction. So basically it's going to reflect on over the x-axis. So basically all this is saying is some stuff that I think we already knew. So let's take a look at this first one here and put all the pieces together. So sine of a negative theta equals negative sine theta. Now, we knew this when we were going to go and when we were doing out trigonometric identities, okay? I'm sorry, trigonometric ratios. And to model this is that if I had the sine of, say, a negative 30 degrees, the way that we did that is that we knew that it would go back, say if theta was a negative 30 degrees there, and it would land in cosineville. So if we were going in the opposite direction, all right, this direction, it's going to be a positive because that's where everything for sine is going to be positive. But if we go in the opposite direction, it's going to land in a quadrant where it's going to make sine negative, okay? So that basically means is that we knew that that was going to be negative, okay? And then we just took the absolute value of the reference angle, okay, the angle that is going to the terminal side with the closest x-axis there, and that is just going to be the sine of 30 degrees, which is going to give us a negative 1/2, okay? And so this is just stating all of those in the same general form, okay? So sine and tangent work out the exact same way. The only difference is going to be this business of cosine, and let's take a look at why that is. So if with cosine, if I started off with cosine of a negative theta, the way that we could take a look at that is that cosine would be positive here, and cosine, if I go in this direction, is going to be positive as well. So if I move in a positive or negative direction, cosine is still going to end up being positive if it's its reference angle. So we would just have the cosine of theta. To put some numbers to that, we can again say cosine of a negative 45 degrees, okay? So the cosine of a negative 45 degrees is going to be, right, we know that it would be going in this direction right here, but it would still be positive because it landed in cosine's quadrant. So we could just say is going to be the same thing as a cosine of 45 degrees, which we know that both of those are going to be root 2 over 2. So that's kind of a roundabout way of why those worked in regards to the unit circle. And it is the same thing works out for the reciprocals over here as they did for their counterparts. So that's how you do that, and we're going to jump into doing some trig identities, rewriting some trig expressions, and trying to get them look like one other side of their equality there. So you'll see when I get there, or when we get there. So see you in the next video.